Hi, this is for Molly and for Bailey. Bailey, I have a message for you, and that is on the homework that I said we were going to do, where it was 4.1, number 17A, 18A, and 19A. I think I said that for Friday, but you were here Friday, so you know that didn't happen. That's going to be moved to today. Also, on that lesson, it said 21, 22, 23, and 24. You can axe those. We're not ever going to do them. So, all right. So just a little note to you, trying to keep you up of where we are on the schedule that I gave you. And so hope you're doing well. Molly, hope you're okay as well. All right. What happened is we forgot to turn on the video, so I'm going to review what we just did to begin this class. So, Abby, this one's for you. Do you see where this question goes on the comp book? It's on page 93 on flap number what? 2. So we already had one that asks what are 5 angles that are coterminal to 30. So we're going to squeeze in, now that we are practicing radian measure, we say what are 2 angles coterminal to pi over 5. So I drew one here. Let me redraw it real quick so you can see. So pi over, if this is pi all the way over here, remember pi is 1/2 the circle. So I'm going to go and just eyeball about 1/5 of the way over, and I'm just going to call that pi over 5. So that visual will help me figure out the 2 coterminal angles. So, Abby, what is a coterminal angle? Can you remember for us?
Yeah, there's angles that share the same initial and terminal side.
All right, so they're going to start here, if I had colored chalk, and they're going to end here. Are you okay with that idea, Abby? If you start here and end here?
Yeah.
That's the initial, that's the terminal. So now that we're working on pi over 5, how can we do that? Well, one way is to go backwards and start here and end here. And in order to do that, we noticed that a whole trip around the circle was 2 pi, but we stopped pi over 5 short. So 2 pi minus pi over 5, we did it in the fraction work actually above. We changed 2 to 10/5. 10/5 pi minus 1/5 pi is 9/5 pi, and then we remembered we went in the funny direction, which is negative. So negative 9 pi over 5. Notice the math did not give you the negative sign, so you had to know that you were going the wrong way or the opposite way we normally go. So that is where the negative came from. So then, Abby, we decided to do the same thing, start here and end here, but go in the positive direction. But that made us loop-de-loo. Remember, we had to go around once and then overlap. So to get that value, we had to go all the way around one whole circle, 2 pi, and add another pi over 5. So that was 10/5 plus 1/5 is 11/5 pi. And that's all you missed by coming in late. Pardon? Yeah, what is that? Snowplow? Look out and see. We're hearing some strange sounds here. So Hannah, are you timing us?
Yeah.
Okay. You can't see it from where you are?
No, it's nothing outside.
It
Sounds
must.
like it's coming from this cocktail. It sounds like it's coming from over there. Yeah. Oh, no, you're right. Wait.
Interesting.
It's definitely coming from over there.
Yeah. Look in that corner.
I do not know
It
what
sounds like
it
a
is.
generator.
Yeah.
It sounds like it's coming from right here.
What?
Like, go sit in that corner and then come here. It fades over there, but then like duck down right there.
I think it's outside.
It's really loud over there.
It's a car.
No. Why does it sound like a car?
It's a
Oh,
plane.
yeah, there it is over there. What is it? See? It's looking the right
Excuse
way.
me. What is it?
Oh,
It is. It's salt.
A salt truck?
Yeah.
that's so cool. It looks like it's snowing and sparkling.
It does.
All right, come on back. I don't want to waste any more of the tape. we heard a weird sound, and it's a salt truck. So it's mystery solved. Okay. All right. Now we're ready to go over to pagey 95.
Yep.
And we have 2 flaps. They're yellow there. And are yours in already? Let me show.
I wasn't
Molly
sure
and
how to put it in.
Bailey. It doesn't matter
Oh, okay.
how you flap them. Sorry. So we have 2 flaps here, like that, on page 95. So when you get in, I have some flaps for you.
Thank you.
I'll let you put them where you can find them. All right. I don't think they're out of order. We're gonna call the top special triangles.
Is that the
because
title
you-
of everything, or is that the top flap?
Yeah, that's the title. Special triangles, because you're special. And you've seen this all in geometry, so we're gonna blitzkrieg it. Today is, we were, just so you know, I know you know, Molly, but Bailey, we're 2 hours late today because of about 1.5 inches, would you say, of snow? But it was very crusty. It was, the temperature was like 8 or something, so it was very slippery, crusty snow.
It was 12 when we got here.
12 here when we got up and got here 2 hours late. It's still only 12. Imagine that, Bailey, where you are. All right. Let us draw under flap number 1. I mean, on top of flap number 1, you can say, what is the first special triangle? And the second one, you can say, what is the second special triangle?
Is this the 3069?
Yes, that's all it is.
So what is the first and then what is the second?
Yeah, I don't know what else to call them, first and second. They're not in any special order. I will teach them in order, obviously, in a order, but it won't matter which order we do
Is
them.
this all we're going to be writing?
Yeah, on the top, that's all. So the first flap says, what is the first special triangle? And the second one, what is the second special triangle? And we have about 12 minutes, so that's probably, we'll do that, and I'll show you how to use those to do some of our problems, our response, and give you a little assignment, and that'll be it for our 12 minutes together. All right. First of all, under flap number 1, we're going to develop this first special triangle. Draw a triangle that has all sides equal. Do you recall the name of such a creature?
Oh.
It's there.
I know
Isosceles.
it.
No, it is
No.
isosceles, but it even
But
goes
it's-
beyond that.
It's not gonna be right.
Equilibrium. No,
Equilibrium.
That's physics.
All
We're
right. This is the equilateral creature.
Equilateral. We were so close.
All right, equilateral. So you guys were getting close. Do you recall what is the degrees of the angles in a triangle that is equilateral, like
180
this
divided
one?
by 3.
Which is
40, no, not 45.
60.
60, right? All right, 60, 60, and 60, and that you come to me knowing that sort of thing. So I'll just flunk it down and use it. Now I'm going to take this and I'm going to drop a line straight down from this vertice to the base opposite in such a way that it intersects perpendicularly.
A perpendicular bisect.
So yes, and so some things are fresh as if you did it yesterday. All right, I'm going to pick out this side. It didn't have to be this side, it could be the other side, and move it over here for careful scrutiny. So give me the angles now. They've changed a little bit. So Hannah, what's this one?
That is 60.
Yeah, that one hasn't changed. But what about up top here, since we dropped that line straight
That's a
down?
90 degree.
Pardon?
90.
Well, this is 90. But
Oh,
what
I thought
about
that's the one you were pointing to. 30, sorry.
30, okay. All right. So let's call it the 30, 60, 90 triangle. That's the name of it, and it's very special. And it turns out that if we start with a certain number on the sides of the equilateral triangle, probably the easiest one to start with is a 2, because we're going to cut it in half. If we start it with a 1, then we would end up with a half here, which is fine, but let's keep the numbers whole. So go back to your equilateral triangle and call each side 2 in length. So write a 2, 2, and 2. And now in the one that we have moved over here, they're going to change. So Allie, what's this side now?
2,
It's still 2. What's this one?
1.
Right, do you see where she got that? We took the length of 2 and cut it in half. Now we need to pythag to get this one.
Oh yeah.
So pythag, this is the hypotenuse. So we have 1 squared plus the side that we're looking for. I called it S squared equals 2 squared. So keeping it not as a decimal but as a radical, what does this show up to be?
Square root of 3.
S squared equals, this is 4, the 1 runs over, becomes a 3, right. Square root of 3. We take the square root, we get a plus or minus, but a side of being negative square root of 3 long doesn't make any sense, so we can drop that and just use the positive one. Alright, this has to be memorized right here, and you probably, do you have a little, I know it helps me, do you have an aid that helps you? Do you remember memorizing this in the past? Well, I see it says 1, 2, 3, and the 1 is small, and it's across from the smallest.
Yeah.
Oh yeah, that's what we did.
And the 2, I think, it's on the hypotenuse. Did you hear the word 2 in there? Hypotenuse. So I get the 2 from the word hypotenuse. And then I know the last one has to be a 3. I have to remember that it's square rooted. Anyone have anything better than that?
Maybe that it's the one that is the cut, so it's weird.
Okay.
Yeah, that's.
All right.
Yeah.
Whatever, you need to know these. And I can spin this all around, so I don't have to be in this position. I could go like this and say this is my 90, this is my 60, and this is my 30. And you just have to get them in the right position. Let's see, Abby, what would be this one over here?
That would just be 1.
All right, and then this one, Abby?
That would be 2.
And then square root of 3. So you have to be able to get it in any which way. All right, it turns out now that we might only get to this one. Let's go over and make our response to this, and then we'll come back and do our special triangle. So, also, over on your response side, so that's what, page 94, we're going to write down something, a blast from the past. I'll leave this up, I don't think I need anything else. But are you aware that any 30-60 triangle is proportional to this? So if I have one that starts here and goes to the moon and it makes a 60-90-30 triangle, it will, it'll say that the moon is 600 miles from here. I don't know how far it is. It's probably a lot further than that.
1,200.
So this would be 1 times 600, square root of 3 times 600, and 2 times 600.
237 thousand miles.
Yeah, I just didn't want to multiply that number. What's something that's 600 miles from here?
LA. I don't know.
No, that's like 2,000.
Yeah, it's a lot more than that.
600.
Boston, New York.
Yeah, maybe Boston or New York. So if we had a triangle, you forget the moon comment. If we had a triangle that goes to New York and it's 600 miles away, even though the numbers will be different, they will be proportional to these. So,
We're out of time.
okay.